Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is first element counting. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A of n distinct integers. We define function of x as the index where which has the minimum value of absolute of element at I minus x. And here I the index will range from 1 to n. In case there are multiple indices I with the minimum value, we'll choose the one with the smallest value of element. Now our task is to count the number of integers x such that f of x is I for each value of our indices. And in case some answer is infinite for some indexes, we'll simply print -1. So here what we mean is, we have this array A, then for each index I, we need to give a count of x in such a way that the absolute value of ai minus x is smallest among all the elements that are present here. We need to do this for all integers, and for any index I, if this value is infinite, we simply print -1. For the input format, we have t test cases, and for each test case, we'll have two lines. The first line will contain the integer n. The second line will contain n distinct integers a1, a2 till an. As for the output, we have to output n integers, that is, the number of integers x, such that f of x is I for each of the indices. As for the constraints, number of test cases will go from 1 to 10 raised to 4. Value of n, that is length of our array, will go from 2 to 2 into 10 raised to 5. And the value of element in our array A will go from 1 to 10 raised to 9. Let's see some sample inputs. For the first sample input, we only have two elements with us, that is 5 and 2. First, let's sort it. So now this becomes 2 and 5. Now in this manner, if you want to choose some x in such a way that if we subtract it and get the absolute value, it will be the smallest. As you can see, there are infinite integers before it. It would mean that we can choose as many x as we want. Therefore, this would give us a -1. Same will go for 5 because after 5 there are infinite x that we can choose. So here also the answer would be -1. As you can see, that's the case here. Let's see how we can approach the solution. So all in all, what we want is, let's assume that first we have sorted our array. We'll go on why we do this. So let's assume that this is now sorted. If this is sorted, we have a of I, we have the previous element a of I minus 1, and we have the next element a of I plus 1. So now what we want to do is, we are trying to find x minus a of I, and we want to say that this is smaller than all other elements if x is subtracted with them also. It would mean that there is some range, right? This element is greater than a of I, and this element is less than a of I. It means that in within this range, there exists some range here in which if those x's are chosen, then the difference between ai and x in that range will be smallest among all the integers. Since this is absolute, let's divide it into two. First case would be when x is less than a of I, that is, we are talking about this range, and the other case would be when x is greater than this range. Now, in case where x is less than a of I, then we need to find a range in such a way that from this point, if we move to the left, now this x will be closer to ai of -1. So if we take the difference, this will be smaller. So we'll need to find this, let's say, range L, right? Because after this point, any integers that we choose, it will be closer to a of I. Similarly, we'll find this point R in the greater end as well. Now within this range, all the elements that we have are closer to a of I, and if we find their difference, it will be the lowest among all the integers. How can we find this L and R? So this L and R are nothing but midpoint of these two numbers. So in this case, it would be nothing but the previous element, that is ai minus 1 plus ai divided by 2, and in this case it would be ai plus 1 plus ai divided by 2, and we'll find these two mid ranges, and then we can simply get r minus l plus 1 as the number of x's that we can get in such a way that their difference with the element ai is smallest among all the other numbers. We can do this for all the elements. but not for the first and the last element. Why? Because if we go to the first element, there is no range L, right? There is no lower bound. It can be infinite. Therefore, the answer is -1. And similarly, for the last element, there is no upper bound R. Therefore, for these two, the answer will always be -1. And for the others, you simply check the previous element, the next element, find the middles of them, get the range, and that will be our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. We take the input of n, and then while taking the input of our array, we store it as a pair of element and indices. Then we sort it in the ascending order. Once we have sorted this, we will initialize our result as -1 value for all the elements. Then we start checking for the indices 1 till n minus 2. So for each index, we'll find the previous element and the next element, that is our previous lowest and the next highest element. When we get this, we find the ranges, that is the middle of them, as the low and the high. Once we get this, all the integers in this range are the x's for which the difference between current element and x will be the smallest among all the other integers. We do this for all the elements, and at the end we print our resultant array. And as you can see, I've got an EC in my C++ implementation. Let's see how we can do this in Python. Again, for each test case, we call the function solve, take the input of n, then we take the input of our array. With this, we form another array as pair of element and indices and then sort it in the ascending order. Then we initialize our resultant array as -1 for all the indices. Then we go over the index 1 and n minus 2. Because for the first and last index, the answer will always be -1. For rest of the indices, we find the minimum and maximum, that is as previous, and the next element. We find their midpoint, and that is the range. So we get all the integers between that range and assign it to a result at that index. At the end, we print our result array, and as we can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.